Hello folks, we're going to start today's lesson working through our review together. First, this whole chapter so far has been solving systems of equations. So the very first problem asks us to solve this system of equations by using substitution, and they're both already equal to x. So that means they're already equal to each other. The negative 2y plus 10 is already equal to y plus 4 because they're both equal to the same number. So now I'm ready to solve for y. I can subtract y from both sides. Negative 3y plus 10 equals 4. Subtract 10 from both sides. And negative 3y equals a negative 6. When you divide by negative 3, y equals a positive 2. So if y is 2, I can come back over and plug it in for either equation. The second one looks like the easiest one to solve. So what is x? X is 2 plus 4 because y is 2, and that gives me x is 6. So the point where those two lines will meet is at the point 6, 2, and that would be my solution. All right. Then it asked me to also solve by graphing. To solve by graphing, I need to put both of those equations in slope-intercept form in y equals mx plus b form. So I'm going to pause to not use up my time and go ahead and do that off camera. Okay, so on the left of the screen you'll see where I solved the first equation for y, and then the second equation, y, I just took the 4 over, made it x minus 4, but I wrote it in the form that we're used to looking. And I've graphed those two lines, and sure enough, this is the point where they meet, and that point is 1, 2, 3, 4, 5, 6, 1, 2. So 6, 2 is confirmed as our solution. All right, number 3 says the sum of two numbers is 31. So two numbers, we don't know what they are, so let's use our famous x and y. The sum of two numbers is 31. That's what the first sentence says. The greater number, is that x or is that y? We do not know. But the greater number is 5 more than the lesser number. So let's just pick x to be the greater number. X is 5 more than, there's that magic word than, whatever comes after than is going to be written first. So it's 5 more than the lesser number, so the other number must be y. And there are two equations that you can use substitution to find out what are the two numbers. I'll let you finish that one on your own and ask you what you come up with in class tomorrow. I am so excited to get to show you now my favorite way to solve systems of equations, and it's the process called elimination. Now, elimination is tricky. It's tricky. It's tricky to explain. Sometimes it's tricky to work. So let me just jump right in and start explaining it, and then I'll be able to show you better when I work some problems. Okay, so at first, eliminating one variable. How can I eliminate a variable? By getting opposites to eliminate by adding. So 2x and negative 2x, if I add those two numbers together, they go away. They're eliminated. Getting opposites to eliminate by subtraction. So 2x and 2x, if I add those, I get 4x. But if I subtract those, I eliminate 2x. So you're looking for like terms to eliminate. So here are our step-by-step instructions. And let me just show you each step as I work a problem. So number 1, write the system so like terms with the same or opposite coefficients are aligned. So problem number 1, my x's are already aligned, my y's are aligned, and notice I already have a negative 3x and a positive 3x. So I'm going to either add or subtract, trying to eliminate one of the variables. Well, if I add these two equations, since those are already opposites, they'll automatically eliminate. Isn't that fun? Kind of like being the Terminator. You get to eliminate those numbers, and then you have to go ahead and add the rest. So positive 4y plus negative 6y leaves us with negative 2y, and we're adding 12 plus 18 will give us 30. Now we divide by negative 2, and y is negative 15. So I don't want to overlook any steps. So step number 1 was really already taken care of for us. They were already aligned the way we wanted them to look. Step number 2, I added my two equations so that my x would eliminate, and I went ahead and solved that equation. So now I'm ready for step number 3, and it says substitute the value from step number 2. Well, in step 2 I found out that y is negative 15, so I need to substitute it into one of the original equations. It does not matter which equation I use. I'm going to use the first one, probably just because it came first. It really will not matter. So we get negative 3x here plus a negative 60 equals 12. So add 60 to both sides. And negative 3x equals 72. So when you divide by negative 3, x is negative 24. So where do these two lines intersect? At negative 24, negative 15. That point is our point of intersection. Alright, on our next page, I'm going to leave number 2 for you to work, because I think you're going to see that your y will immediately eliminate when you add the two together. So let's talk about number 3, which looks a little different from example number 1, where our y's will not automatically cancel. So what I'm going to need to do is multiply the second equation by a negative. Or you can think of it as, instead of adding the two equations, let's subtract the second equation from the first equation. When you subtract it, then it becomes a negative 2x, a negative y, and a negative 2. Please don't forget the 2 also becomes negative. So now when I add the two together, I'm no longer looking at this equation because I have changed all my signs to make it subtraction. My y's now eliminate, and 4x minus 2x leaves us with 2x, and 12 minus 2 is 10, so x is going to be 5. Now I go back up and I say 4 times 5 plus y equals 12. So that's going to be 20. And when we subtract 20 from both sides, y is going to be a negative 8. So the point where these two lines cross is at the point 5, negative 8. See how quick that is? I love it. It's my favorite method for solving systems of equations. All right, look at number 4. I'm going to make you try that one by yourself. You will need to subtract. Even though we have opposite signs for our y, we have a 2 and a 3. It's the 4x's that you want to eliminate. So multiply this whole second equation by a negative, and then you'll be able to eliminate. So before my time runs out, I would like to work some word problems with you. Okay, so 4 times one number minus 3 times another number is 12. You can just write that exactly how it is worded. 4 times one number minus 3 times another number is 12. Got two different numbers. X and Y are our favorite in algebra. 2 times the first number. Okay, so what was the first number? The first number was x. So 2 times the first number added to 3 times the second number is 6. Okay, they want us to find the numbers. Guess what? That's going to eliminate immediately when I add those two equations together, and I'll end up with 6x equal, 6x equals 18, so x is 3. So plug 3 in. 4 times 3 minus 3y equals 12. And 4 times 3 is 12. And 12 minus 12 is going to be 0. And divide negative 3 into 0. And it's going to be 0. So the point where those intersect is at 3, 0. Those would be the two numbers. It says find the numbers. So 3 and 0 are those two numbers. Alright, and it also went ahead and told us to let x represent the first number and let y represent the second number. I will need to tell you that on the test, and if I don't, you need to be sure and ask me, because technically you can set the problem up either way if I don't give you specific details. Alright, let's read about rentals. A hardware store earned $956.50 from renting ladders and power tools last week. The store charged 36 days for ladders and 85 days for power tools. This week, the store charged 36 days for ladders and 70 days for power tools and earned $829. How much does the store charge per day for ladders and for power tools? All right, so I had to read this problem a couple of times because it threw me off how it says they earned last week, but yet we're talking about 36 days and 85 days, and obviously that's more than a week. So this must be they collected the money from the 36 days that they had rented the ladder, and 85 days they rented the power tools, and that gave them a total collection of $956.50. Then the other scenario was 36 days for ladders and 70 days for power tools, and the collection over that period of time was $829. So I'm ready to find out how much does the store charge. I'm looking for money here because this is money, but 85 is not money. 85 is days, 70 is days, 36 days. So I'm looking for how much money. So my X and Y stands for, or represents, X stands for how much money to rent a ladder, and Y stands for how much money to rent a power tool. And my screen always jumps when I get to the word problem. It must have something to do with my clip art and everything getting jammed in here together. All right, elimination is the easiest way to solve this problem, and I have 36x, 36x, so let's subtract. Let's change all of these signs to negative. Subtract the bottom equation from the top equation, that way I can eliminate the x. 85y minus 70y leaves us with 50. Okay, 85y minus 70y leaves us with 15y equals 956.50 minus 829. So y equals $8.50 a day. For what was y? Y was the power tool. So we have to take that number, plug it in to find x. So 36x plus, we'll do the first one, 85 times 850 equals 956.50. All right, and with the help of my calculator, that'll give me $6.50 for X, which stood for ladders. Go ahead and work through the check your progress problems. There are 4 of those here. But before you go, I need to ask a very complicated math problem that I've been pondering. What do you get when you add 50 female pigs plus 50 male deer? 50 female pigs and 50 male deer. Now you might need to go get your parents because you might need their help. This is a very complicated math problem. The pigs have to be female and the deer have to be male. What do you get? What does this equal? Give it a second to think about it. Maybe pause the video. Well, obviously you get 100 sows and bucks, right? 100 sows and bucks. 100 sows and bucks. Hee hee hee. Have a great day.